Hello, welcome to day 4 of Unit 2. Today we're going to talk about some special congruent angles. So our first theorem for today is right angles are congruent. So this means that all right angles are always congruent, and that kind of makes sense. And you're kind of like, why do we need to say that? Because they're both equal 90 degrees, so of course they're congruent. But it's important in proofs. Because remember, proofs are us stating things so that we can convince someone else of an argument. The idea of a proof is to give them statements and reasons so that we know our argument's true. So here in example 1, we are given that AB is perpendicular to BD. So this is where I really start to like to use different colors, as well as labeling. Whether using different colors or the same colors, it's important that we're labeling. If you're using it in Canva, changing colors is easy. If you're doing it on paper, you might want to invest in some colored pencils. So we know that AB is perpendicular to BD. So there's a right angle right there. And we know that FG is perpendicular to DG. Then we also know, and this is where I'm going to switch colors, that angle ABC is congruent to angle FGE. And then what we want to know, what we want to prove is DBC, I'm going to use 2 marks since it's a different angle, is congruent to DGE. And notice that I chose like kind of an obnoxious color for what I want to prove, so that I remember that's what I want to prove. So let's start off with our givens. So again, we draw our chart here, and this is statements and reasons. And I'm going to be lazy and label it S and R. And then, of course, we always need to write our givens. So we know AB is perpendicular to BD. FG is perpendicular to DG. And we can say that angle ABC is congruent to angle FGE. And that's our given. Now, knowing that AB is perpendicular to BD, that tells me that angle ABD is right. And knowing that FG is perpendicular to DG tells me that angle FGD is right. And that's due to the definition of perpendicular. You could also say perpendicular lines form right angles. Now that I know those 2 angles are right, I can use our new theorem, which says that ABD is congruent to angle FGD. And the reason for that is all right angles are congruent. So now if I look, I do have 2 congruent statements. ABD is congruent to FGD and ABC is congruent to FGE that involve my angles that I'm looking for. And if I really think about it, if I take the blue angle here, which is my right angles, what can I do with that to get my green angles? I want to subtract the purple ones. So that's what I want to go ahead and do. I want to say that angle ABD minus angle ABC, and we should say the measure here because we're subtracting, is equal to the measure of angle FGD minus the measure of angle FGE. And that is our subtraction postulate. Then we know from our angle subtraction that angle ABD minus ABC equals DBC. And we know that angle FGD minus angle FGE is equal to EGD. And that is our angle subtraction. And then substitution says that angle DBC is congruent to angle EGD. Which is exactly what we wanted. So now our next theorem for today is all straight angles are congruent. Okay, so again, I'm going to start out with my colors. So I know ABC is congruent to FD, and FDE are straight angles, which means the first thing I'm going to say is that those are congruent. And then to switch colors, I'm going to say that ABF is congruent to EDC. And I want to prove that CBF is congruent to FDC. So this is very similar to the last proof we just did. So I want you to pause, try it, and then come back and check. Okay, so here you can see my proof. So I started out with my givens. Then I said angle ABC is congruent to FDE. All straight angles are congruent. Then I did the subtraction postulate where I did measure of angle ABC minus the measure of angle ABF equals the measure of angle EDC minus the measure of angle FDE. And I just realized reading it that I have a mistake there. I flip-flop my letters. I should say FDE minus EDC. And if I did that on a test, that would lose points. So I do want to make sure I fix it here. Okay, so then continuing, ABC minus ABF equals FBC, which is subtraction. I have the same mistake down here. I just read the angles wrong when I was doing it. So down here, I'm going to say the measure of FDE minus the measure of EDC equals the measure of FDC, and therefore angle FBC is congruent to FDC. So here's another example that I want you to try, number 3, and go ahead and try number 4. Actually, just do number 3 and then come back. Okay, so welcome back. So you can see what I did is I listed my givens, which I'm sorry, they're a little hard to read. I was trying to write small, but they're just rewritten the givens. And then my first thing I did is I said the measure of angle 1 equals half the measure of EAB. And that's because of definition of angle bisector. I can also do that for the measure of angle 2 equals half the measure of FBC. Again, definition of angle bisector. And then this proof's pretty much done because we know the angle 1 is congruent to angle 2 because halves of equal quantities are equal. Now, number 4 is not a proof. And I want to point out that it says justify your answer. So that means just do algebra or arithmetic and show your work. So it tells me that RST is a line and that it's perpendicular to SQ. But then it says that the measure of RSU is 89, which means, sorry about that, everybody. The bell got me again. I need to pay better attention to the time. Anyway, so where I was is this problem says to justify our answer. So we know that RSQ is right angle, and we know that angle RSU is 89 degrees because that's what they told me. And they want me to find the measure of angle RSQ. Well, the measure of RSQ equals 90. And that one, you can't really show any work, so you're just going to say perpendicular lines. To find the measure of angle QST, that also equals 90 because it's also perpendicular lines. Then to find the measure of angle TSU, for that one we got to do a little work. So we're going to do 180 minus 89, and we're going to get 91, and you're going to say linear pair. And that's really all there is to justifying our work. So again, tomorrow in class, we'll continue on with the classwork problems. Sorry about this.